So here I want to talk about a very special number, which is called complex number. So we have learned many numbers. So far we have discussed the number which is a real number, right? Which is corresponding the point on the x-axis. So now, in general, we say, okay, x squared, but if there is no specialized, we always treat the number as a real number, right? Otherwise, the problem will point out this number should be a complex number. Okay, so in general, if you have this equation, right? Then we say, okay, we subtract 1, so your x squared equals -1, but we know x squared is always positive, right? It's -1 if x is a real number. So we say, okay, have no solution. This one has no solution. But actually, this word is not very precise, right? Actually, we mean, it means no real solution. Okay, so that means x is a real number. Then we say, if x is a real number, then we say there is no solution. So the mathematician want to solve this kind of equation, x squared equals a negative number. So they introduce which is called an imaginary unit. We introduce an imaginary unit, which is denoted by I. How to define it? we define I is equal to square root of -1. Square root of -1. So we introduce this is the imaginary unit I. I means square root of -1. Okay, so now we can solve this one. So x squared is equal to -1, right? So if we take the square root, we use the square root property. It's plus or minus square root -1, right? So what is square root -1? Square root -1 is I, so it's plus or minus I. So in other words, so this kind of number is actually not a real number anymore, right? Because we can not locate I or -I on our number line, x-axis, right? So this kind of number is called a complex number. Okay, so now let's look at some properties for this I. So we notice that I is square. I square is what? -1 square. A square root of -1 square, so which is equal to -1. So I square equals -1. I cube is equal to I square times I, right? So I square is -1, so it's -I. I to the fourth can be written as I square times I square, which is -1 times -1. So this is equal to 1, right? So if the power is greater than 4, then we need to divide this power by 4, then locate the remainder. Okay, what does this mean? This means if you have xi to the 14, so we know that 14 can be written as 4 times 3 plus 2, right? So it can be written as I to the 4 times 3, then plus 2, right? So it's equal to I to the 4 times 3 plus times I squared. So what's this? This is I to the 4th, then to the 3rd, right? Times I squared. I to the 4th equals 1. Wait, no. 1 to the 3rd is 1. So this is 1, then times I squared. So which is I negative 1. So this is negative 1, right? So if you have, for example, if you have I to the 41, so this is the equal to I can be 41 can be written as 4 times 10 times I, right? Sorry, just plus 1, so it means I 4 times 10 times I to the 1, right? So this term is I to the 4 then to the 10, so it's equal to 1 times I. So this is I. So this is the I 37. 37 divided by 4 equals 9 plus 1, right? And then the remainder is 1, so it's equal to I to the remainder. So it's equal to I. Right? So this is the basic calculation for i's. So the definition for the complex number. So in general, complex number can be written as A plus B times I. So here, A and B are real numbers. Real numbers. Okay, and A is called, give A is name, which is called real part of this number. And B multiplied by I, B is called the imaginary part. You cannot combine the real part A and the real part, imaginary part B. You just separate. Okay? You can treat I as a number, right? So there is a remark. The first one. If A is 0, but B is not 0, for this case, so it becomes B times I, right? This is called pure complex number, imaginary. This is called a pure imaginary number. Okay, sometimes we call it a pure complex number. If A is not equal to 0, but B equals 0, then this number becomes A, which is a real number, right? So the complex number becomes a real number because A is a real number, right? So from this case, we notice that the actually complex number contains more numbers than the real numbers, because complex number, real number is just a special case of the complex number where A equals 0 and A is not 0 and B equals 0. There's no imaginary part, then it becomes a real number. If there is an imaginary part, it's another number, which is not a real number, right? So the real number is a special case of complex number. Real number is a special complex number where this imaginary part equals 0. 3. So now let's look at how to locate. We know we can locate all the real numbers on our x-axis, right? On our x-axis, all the real numbers can be located here. Okay, so where is the imaginary part? Where is other complex? Since real number is a special complex number, what about the other complex number? The other complex number should be here in the space. Okay, so these are the other complex numbers. So now let's look at how to find a plus by, bi. So here, x-axis is the real number, and y-axis is actually the pure imaginary part, imaginary number. Okay, so let's look at this a plus bi. A plus bi, a is a number here. We can treat a plus bi as what? As a pair of numbers, because a plus, this complex number is determined by a and b, so we can write it as a comma b. There is a one-to-one correspondence between the point and this number, right? So this b is the y-axis, y coordinate. So this is b. So a plus, so this is point a, b. It also represents as a plus bi. Right. So the point a, so a plus bi, the number is actually corresponding to the point ab. So if you have this one is, let's use another color. This one, this is, for example, this is 3. Right? Y coordinate is 3. So what is the number corresponding to this number? This number is, well, x-axis equals 0, right? X coordinate of this point is 0. The y coordinate is 3. So this is the 3i. So all the points on the y-axis is actually the pure imaginary number. So this is the real imaginary number, which is a special complex number. And here is, this is the pure imaginary number, which is also a number, imaginary number, which is also a special complex number where a equals 0 and b is not 0. And here is still 0, 0. Right, this is 0, 0, this is 0 plus 0i. So all the points in the space are in the plane corresponding to a complex number. Okay. So example, so we want to locate, where is locate I? Okay, so we can written as I as a 0 plus 1 times I, right? So there is corresponding the point which is the 0, 1 point. 0, 1 point, so which is here. 1 here. So this point is I. Okay? So now let's look at the operations for the complex numbers. So the first operation is, if you have two complex numbers, a plus bi and c plus di, if these two numbers are equal, what does this mean? This means, it's if and only if two complex numbers are equal, that means the real part equals the real part, and the imaginary part equals imaginary part. Okay. if you have a plus bi, this is one complex number, plus c plus di, another complex number. So what is this one equal to? This equal to, we combine the real part and combine the imaginary part. So this is a plus c, real part plus real part, plus imaginary part plus imaginary part. So this is bi plus di, we take I out, so it's b plus d, then times I. Okay, you can treat I as a number, but this is a very special number, which is square root 1, negative 1, square root negative 1, right? So if you have a plus bi minus c plus di, so a complex minus another complex number. So the same thing, real part minus real part, imaginary part minus imaginary part. So it becomes a minus c plus b minus d times I. If you have a c times a real number c times a plus bi, so we can just do as usual the distribution law, c times a plus c times b times I. Okay, so now let's look at some examples. If you have 1 plus 2i plus 3 minus 2i, so real part plus real part, so it's 1 plus 3 plus 2i minus 2i, right? So real part, do the operation on real part and do the operation on imaginary part. So this one is equal to 4, this is equal to 0, right? So more complicated, 3i minus negative 2 3i plus minus 2 plus 5i. Okay, so we just the 3i minus, it becomes what? Plus, with negative 1 times each term, minus 3i, right? Minus 2 minus 5i, which get just as usual get rid of the parentheses. Then the real part is positive 2, negative 2, so it's positive 2 minus negative 2, right? The imaginary part plus 3i, negative 3i, negative 5, so 3i minus 3i minus 5i, right? We put the imaginary part together and put the real part together, we separate. Okay, so this is 0 plus, so this is the 0 minus 5i equals negative 5i. You just treat I as a number, right? As we did as usual, right? Do the operations, so it's equal to negative 5i. So now let's look at another operation, which is the fourth operation, which is a complex. So this is a real number times a complex number, and that is a complex times a complex number, which is a plus bi times c plus di. So I don't want you to memorize this formula. Why? Because you can get this result just as we did for before, as if you treat I as a number. We just expand it, okay? So this is a times c plus a times di, a di, right? Plus bi times c, which is c bi. You just treat I as a number. And bi times di, so which is b times d times I squared, right? So this is ac plus adi plus cbi plus bd times what? I squared equals, remember, it's equal to negative 1. Okay, so this is we combine the real part and the real part. This becomes a real number, right? Then put the imaginary part together. So it becomes AC minus BD plus I times AD plus CB. Right, we take I out. So this one is our result, right? You don't need to memorize. It's too complicated. You just, as usual, we expand. Okay, so this is 2 minus I times 4 plus 3I. Okay, so how do we do that? We just expand it. So it's 2 times 4 plus 2 times 3I minus 4I plus minus 3I squared, right? So it is 8 plus 6I minus 4I and plus 3, right? I squared equals -1, -1, negative, it becomes plus. So 8 plus 3, right? It's 11. And 6I minus 4I equals 2I. Just treat I as a number. Another example is 3 plus 2I squared. So just as usual, a plus b squared equals a squared, 3 squared, plus 2 times 3 times 2i, right? Plus 2i squared. This is the formula, right? A plus b squared. A plus b squared is equal to a squared plus b squared plus, plus 2ab plus b squared. Right, plus b squared. So this is 9 plus, this is the 12i. Okay, so this is the 4i squared, right? 2i squared, which is 2i times 2i, which is 4 times I squared, right? I squared equals -1, so it's -4. So this is 5 plus 12i. So another special, if you have a complex number a plus b, there is another number which is called a minus bi, a plus bi. So these two numbers are always as a pair. Okay, we always treat these two complex numbers as a pair. Why? Because we give a name for these two numbers. This is called complex conjugate. Complex conjugate. Okay, why? These two numbers are very special. The reason is, if you multiply together a plus b, so let's look at this as a remark. A plus bi times a minus bi. Okay, we know that if you have a number x plus y times x minus y, if you expand it and simplify, it's equal to x squared minus y squared, right? It becomes x squared minus y squared. So we use this idea, we treat I as a number, so this is the so x plus y times x minus y. So it becomes a squared plus minus bi squared. So bi squared equals -b squared, right? So it becomes a squared plus b squared. So the result is, if you multiply these two conjugates, okay, if you multiply the conjugates together, the result is a real number, right? So a plus bi times a minus bi is actually equal to a squared plus b squared. So you need to know that. Okay, we can make, if you have a complex number and we multiply the conjugate of this complex number, the result would be a real number. Okay, so let's look at this one. If you have a 4 minus 5i, you multiply this number by its conjugate. Conjugate is just to make the imaginary part to be the opposite side. Okay, so the conjugate, so this is the, so you can see these two numbers, same real part, the same real part, opposite sign for imaginary part. Right. So the conjugate would be 4 plus 5i, and the result you can get quickly is equal to 4 squared plus 5 squared. So this is equal to 41. So it's a real number, right? A complex number times its conjugate equals a real number. Why this is useful? Because if some complex number in the denominator, right, we want to simplify it. For example, for this one, we want to simplify it. In other words, we don't want to see any imaginary part in the denominator. What we should do? Let's multiply this denominator by its conjugate. So to keep the same, we also need to multiply the top by this number, this complex number, right? So it becomes, the denominator is 4 squared plus 2 squared, right? And the numerator is, we just expanded, 2 times 4, 8. 2 times 2i equals 4i. 3i times 4 equals 12i. And 3i times 2i equals negative 6, right? Oh, you just, let's write one more step. 6i squared. So it's equal to, this is the 20, and this is the I squared equals negative 1, so it's negative 6. 8 minus negative 6 equals 2, then plus 16i. Let's simplify anymore. Continue to simplify. Let's divide by 2. There's a common factor 2 on the top and the bottom. So we divide by 2 on the top and the bottom. So it becomes here 10. Here's 1 plus 8i. So you can see this number is actually equal to this number, right? These two numbers are the same, but for this new result, our denominator is a real number, right? So here, the next thing, let's look at, if we assume we let a is greater than 0, which is a real number. Okay, so how to get rid of the square root? Okay, so this one can be written as square root of a times square root of negative 1, right? Because negative a equals negative 1 times a, so it becomes this one. So it becomes what? Square root a times I. Square root negative 1 equals I. So any number, can be written as, this one is square root of 16, which is 4 times I. 4i. (13), which is square root 13i times I, right? let's look at this example. Negative 14, square root negative 14 times square root 2. Okay, so we know square root negative 14, which is square root of 14 times I, times square root negative 2 equals square root 2 times I. So it's equal to square root 28 times I squared, right? 28, square root 28 equals what? Equals 2 times square root 7. It's 4 times 7, 4 square root is 2. Then times negative 1, so it's equal to negative I 2 square root 7. So square root of negative 14 times square root negative 2 equals 2 times negative 2 times square root 7, which is a real number, but it's a negative real number, right? So here is a very interesting thing, and many students will make mistakes. We know that if we have this kind of this property, right, for the square root. But we notice that this formula is not valid for both a and less than 0 and b less than 0. Okay. If one is less than 0, another one is greater than 0, that's fine, you can separate. But if both less than 0, you cannot separate. For here, we can separate, right? We can separate as this one, right? But because here a is greater than 0. However, if a is less than 0 and b is less than 0 also, then we cannot separate. The reason is this example. If we assume if this is true, it's not equal to, we should write another word. So we know that square root negative 14 times square root negative 2, we just calculate it's equal to negative 2. Okay, so now let's look at square root negative 40. If we combine it, so this is the square root 28, which is 2 square root 7. So you can see these two are not equal. These two are not equal, right? So remember, this is only true for one of them. At least one of them is greater than 0. Greater than equal to 0. If both less than 0, you cannot use it. Okay, so now let's look at this one. This is the solution for the quadratic equation. Complex number will be often used in the solution for the quadratic equation. Right, this is the 3x squared minus 2x plus 5 equals 0. Right, so do you remember the discriminant? If you have, I put another color right under this one, right? If you have ax squared plus bx plus c equals 0, so there is called the discriminant. Discriminant is b squared minus 4ac, right? So if this one equals 0, we only have one solution, right? One solution. If this one is greater than 0, we have two solutions, two different solutions. If this one is less than 0, we have, say, no real solution, right? Before we say no solutions, that means it's no real solution, but actually it means no real solution. So here, the discriminant is b squared. B is -2, so it's -2 squared minus 4ac. 4 times a is 3 times c is 5. So you can see this is 4 minus, this is the 60, right? So it's -56. So it's less than 0. So that means no real solution. No real solution. However, if we consider the complex number, it actually has a complex solution. So how to calculate? We're using the quadratic formula. The quadratic formula says it's equal to negative b plus or minus square root b squared minus 4ac divided by 2a, right? So we plug in the numbers. We have b equals -2, so it's -2 plus or minus square root -2 squared minus 4 times a is 3 here, right? 3 times c is 5, then divided by 2 times a equals 3. So this is 2 plus or minus square root. We just calculate this number is equal to -56, right? We just calculate here. So this is divided by 6. Okay, so we know this one can be written as square root 56 times I over 6. Let's simplify it, because this 56 can be written as 4 times 14. So if we take the square root, so this is a bit, both numbers are positive numbers, so you can separate, right? So this is 2 square root 14. So it's equal to 2 plus or minus 2 square root 14 divided by 6. So it's divided by 2 on the top and the bottom, 1 plus or minus square root 14 over 3. Sorry, here is I. So you have two real numbers. One is 1 plus square root 4 times I divided by 3. Another one is -1 minus square root 4i divided by 3. So actually these two complex numbers are conjugates. Right? So the solution for the complex numbers always appear in pair. So that means if you have one complex number as the solution, you must have the other, its conjugate, as its also as its solution, right? Why do we say these two are? It actually can be written 1/3 plus square root of 4 over 3 times I. This can be written as 1/3 minus square root of 4. You just divide by 3 as usual for each term. So this is just the part, a quick introduction for the complex numbers.